All right, so in this video, we're going to talk about how to interpret your estimates of the coefficients, so those B's. How do you interpret them in a multiple linear regression model? So just to recap, we're in the middle of this discussion where we started it by doing a scatter plot matrix of our raw data. We showed how to figure out the least squares estimator using matrices. And then we went ahead and used the data analysis tool pack to, tell us some information about, the residuals, and it gave us all these beautiful plots. And so this was our original model, right? With just like the raw data before we transformed anything. And there were problems with this raw data. We kind of had some separation with BMI that we wanted to try to address. So we went ahead and we did some interaction terms, and we ran the regression again with this BMI and smoking interaction that we thought was important, okay? So here at this point, we were like, okay, let's look at our residuals and see how things are going. We said these residuals aren't normal, so that's a problem. I can't really interpret these beta parameters until those residuals look normal. So then we went and we did some data transformations. So I want to pause here and talk about how to interpret these coefficients before I did the transformations. Okay. Now, of course, your p-values, your confidence intervals, your hypothesis test, anything that involves a distribution assumption is invalid when you have not checked your residuals. But, if we can still interpret these coefficients, we can't make any distributional assumptions of these coefficients yet. So let's talk about how, before we do the transformation, first, for like a multiple linear regression model, how do you interpret coefficients? Okay. Starting with, we'll start with this age coefficient here. Okay. So remember our model, it is y, which is the insurance cost, equals the intercept plus beta 1 times the age for the first person plus beta 2 times the BMI for the first person, or for the ith person. And I'm just going to do ... for all of these different, it looks like I have through x9, so I have until I get to beta 9, right? And this is going to be our interaction term between B2 and smoking is B4, or X4. And then we have model error. Okay, so, this is our model. And then, of course, we have a prediction, which uses these coefficients, right? And these coefficients this is B, right? So B naught plus B1, X1I plus B2, X2I plus ... all the way till I get 2. There's no model error, so it's just till I get to B9, X2I times X4I, because that's an interaction term. Okay? Okay, so how would I interpret, let's just do, the easiest one is just this X1. Or this B1 interpretation. How do I interpret B1? Okay. Well, what we want to do is we want to think about if we were to increase this X1 by 1 year, right? How does that affect Y, right? And of course, and we want to basically hold everything else constant. That's difference between making interpretations of a simple linear regression model and a multiple linear regression model. In a simple linear regression model, you don't have other things to hold constant, right? But in a multiple linear regression model, you do. So you need to hold everything else constant while you're making this interpretation of this guy. Okay, so what we'll do is we'll create, this y, we'll call this 1, right? And then yi2 will be this same model, but the x value will go up by 1 year. okay, dot, 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 B9. All the other x's stay exactly the same, okay? So now if you were to subtract B, or the second, right, the increase minus the first, right, what you would get is everything, when you do the subtraction, everything will cancel, and when you FOIL this in, right, this term B1 times X1I will also cancel, and you'll be left with just B1, okay? So for a unit increase in age, right, that's what this is showing. For a unit increase in age, we expect that the change in price or the cost of insurance, charges for insurance, will increase by $263 as long as you hold for the BMI, everything else constant. Okay. Now interpreting terms that have interactions, this gets a little more tricky. Okay. So next, let's go ahead and let's try to interpret for an increase in 1 BMI. Okay, so this one was for, let me write this. So for each year increase in age, we expect charges to insurance to increase by $263 for each or when all other variables are held constant. Okay, so now how do we interpret a, let's go ahead and do, so if we have y hat 1, and this is just going to be b1 x1 plus b2 x2 plus dot 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 b9 x2 times x4, because that's an interaction term. Okay, so now let's say BMI increases by 1 unit. Okay, so the second one will be b0 plus b2 x1 plus b2 x2 plus 1 plus dot 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 b9 x2 plus 1 times x4. All right, and let's simplify this. This is b9 x2 plus, well, go ahead and multiply that also by x4 plus b9, right, this times 1, times x4. You still have that x4 being multiplied, right? So it's b9 times x2 times x4, and then b9 times 1 times x4. Okay. And this is b2 x2 plus b2, and this is still all the same stuff everywhere else that doesn't involve the 2. All right, so when you take the difference between when you have an additional unit of increase in BMI minus without, you can see that everything cancels except this guy and this guy. So this is B2 plus B9 X4. Okay, so the way you would need to interpret this, so what is X4? X4 is a smoker. So it's yes, no. So yes is 1. So we would need to basically, so let's say we would have to interpret it for both. So we would say for each unit increase in BMI, right? That's what I did, is I increased BMI, right? That's what I did right here. So for each unit increase in BMI, when someone is a smoker, or increase when someone is a smoker, we expect insurance charges to increase by, and the way we would write this is it would increase by, so you would basically plug in 1 because it says when someone is a smoker, so increase by B2 plus B9. So I would need to calculate that. So let's go up here. B2 is this number. So let me write this here. B2 plus B9 equals B2 plus B9 is this guy. So 1467 if I round that. Increase by $1467. Okay? And so this is that's one interpretation. Another interpretation is for each unit, so also with all other variables held constant. You need to write that, okay? So with all other variables held constant. So the same number of children, same age, all that stuff. Okay, so for each unit increase in BMI when someone does not smoke. When someone does not smoke. Now, so if you do not smoke, this X4 is 0. Okay, so we expect insurance charges to increase by whatever B2 was. Okay, so what is B2? If I scroll up, B2 is $24. I'll round that by $24. Okay, with all other variables held constant. Okay, so wow, that's a pretty big difference, right? So that shows that interaction is pretty strong. So yeah, that's why we would interpret for this model, right? Without any transformations, right? Now, when you have transformations, things get a little tricky, unfortunately. But the way we do it is very similar. It kind of looks a little messier. So remember, my residuals were messed up. So I went ahead and I tried a transformation. First thing I tried was the ln transformation. But I still had the large tail. So I was like, okay, let me do the inverse transformation, which is like basically 1 over y. And my residuals looked a lot better. So this is the analysis that I actually want to interpret my confidence intervals. This is the model that I actually want to use. Okay, so how do I interpret these coefficients? All right, but of course, the interpretation gets a lot more complicated when I have 1 over y instead of just having y. So what does my model look like? My predicted model is 1 over y equals b naught plus b1 x 1 plus b2 x2 plus dot 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 b9 x2 x4, right? That's that interaction term, okay? So, for example, if I want to interpret, let's say I want to interpret B1, right? I want to know how much does the charge increase for when age increases by 1, okay? And, before we could just, say, figure out what it is when you have the increase and subtract off what it was before you had the increase, and then that's going to be the difference in the charge, right? And so if this is the cost before the increase, then this is basically going to be, so after the increase, let me go ahead and write that down here. So after the increase, this will be 1 over y2, which is b naught plus b1 x1 plus 1, right? So that's your increase. b2 x2 plus dot 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 plus b9 x2 x4. And of course, you know, you can rewrite this. You could distribute that. So this is b1 x1 plus b1. Okay, so you know, before, when this was just y on this side, when you did your subtraction of the two different y's, you know, basically everything cancels except for this term here. And that was a really nice interpretation where you could say, okay, for a unit increase in age, you know, the charge increased by this much. But now, if I want to know what is the difference in the charge, so how much did the charge increase, I need to solve both of these equations for y, right? And let me go up top here, so let me use a different color. So if 1 over y is this, that implies that y, if I were to, you know, basically divide both sides and then, you know, multiply both sides, this is the same thing as y equals 1 over all this jazz, right? Just using algebra, I can rewrite this. This is what y1 is. Similarly, y2 is the same thing. It's 1 over all that jazz. Okay. So now, when I want to figure out this difference, that's what I'm going to be plugging in. I'm going to be plugging in these nasty fractions. Okay, so this is going to be equal to 1 over b naught plus b1 x1 plus dot 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 plus b9 x2 x4. Okay, you start with the second one, so plus b1, okay, plus this, okay? Then that minus this stuff over here, so 1 b naught plus b1 x1 plus dot 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 b9 x2 x4. Let me scroll down. All right, and I can simplify this to make this into a single fraction. So let's do that. When you do that, this part here goes up here, so we get b naught plus b1 x1 plus dot 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 b9 x2 x4. Okay, then that minus this stuff over here, so b naught plus b1 x1 plus b1 plus dot 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 b9 x2 x4 divided by, you gotta FOIL that out, which is going to be a mess, so I'm not going to do it. I'm just going to leave it like that. Dot dot dot. Okay, times all right, so then in the numerator, you see you have some nice cancellations. So b naught cancels, b1 times x1 cancels. This guy stays, but notice he's still negative. He's negative there. b9, x2, x4 cancel. So you're left with, in the numerator, all you have is negative b1. And then in the denominator, you still have all this stuff here. So b naught plus b1. And actually, I mean, you could just write this using, you know, our matrix notation. So you would have whatever x value that you're plugging in. So I could make a vector of x's that I'm plugging in. So starting with the first would be 1, and then x1, x2, all the way. So something that I'm plugging in, right? And then that times, that transposed times b, where b is b naught, b1, so all of the coefficients stacked on top of each other. Okay, so that you see, it's just it's all right, so in the numerator, I have negative b1. And then the denominator, now notice this is, except for this guy, right? this is X transpose B, right? Where B is all my coefficients, B naught, B1, all the way to B9. And X is just, it's some value that I'm plugging in here. So when I'm making this interpretation, I'm going to need to choose some X values. And the first one is 1 for the coefficient, or for the intercept. And then whatever numbers I'm choosing, so x1, x2, etc. Okay, so yeah, this the guy plus whatever b1 is. Okay, so I still have this plus b1. So it's that times, and then this guy is just x bar or x transpose times b. All right, so for a unit increase in age, the charge increased by this much, okay? And yeah, that's hard. I'm not going to lie to you. That's hard to interpret. So what does that really mean? Okay. First off, how would I even, that's not even a number, okay? So what I would need to do is I would need to choose so a unit increase in age. So I might say when someone goes from age 24 to 25, okay, how much does their insurance charge increase? Well, I would need to also plug in the other values of X for that interpretation. So I would say, okay, well, assume their BMI, let's see, what were the ranges for BMI? If I go back to my scatter plot, BMI ranges, so 20, so say I were to say 30. So say their BMI is 30. Go back to where I was. Let's see. Okay, so I'm going to create like an X matrix here. So I'm going to say X is the first. So the first I have 1, right, for the intercept. Then I have, let me copy this. Intercept. Okay, so their age, I'm going to start it at 24. BMI, say is 30, say they have no children, say they don't smoke, that they are female, that they're from the Southwest, sure, so everything else is 0. And then the BMI versus smoking or time smoking, so this would be BMI times smoking status. Okay, so this is X, right? This is X. B is all these coefficients here. So I'm going to Control C and Control V them here. All right. So what's happening here? Negative. So let's go ahead and do this formula. So I have negative B1. This is B1 divided by, let me use parentheses. And then let's do X transpose times B. Okay, so that's matrix multiplication. And I want the transpose of X, which is this guy, okay, times B, which is this guy. Okay, then close those parentheses and make sure I'm still in the denominator and press plus. Okay, plus B1, which is this guy. Okay, so you see I have done this, X transpose plus B1. Now I need parentheses around that. All right, and I need to multiply it by X transpose times B. So that's matrix multiplication again. And do transpose, once again, X, and then B. Close parentheses and close parentheses. Let's make sure that I've closed my parentheses appropriately. Okay, good. And good. So let's press enter. I forgot to close a parenthesis for transpose. So close it for transpose. So that's the transpose of that guy, then this guy. Okay, there we go. So take a closer look. So I have the transpose times B plus B1. Okay, that's in parentheses. Then I have the transpose times B, and then close parentheses. Okay. Press enter. Good. So what does this mean? This number I just calculated, right? What does that mean? This is when age increases from 24 to 25, we expect charges, so your health insurance charges, to increase by 20, I'll do round that to 20 or to 63, so round that to $63 when we hold constant BMI at 30, children at 0, no non-smoker, female, because yes to female, living in Southwest. Okay, so notice we still have to hold everything else constant, but when we have a transformation on y like this transformation on y that we're using here, we need to actually specify exactly what we're holding at constant. Versus before, when we didn't have the transformation, we used to just say, oh yeah, when you hold all the other variables constant, right? But it didn't matter what the other variables were. Here it does. When I change, so say I change to male, you see that number changes to now $75. So when a male increases in age from 24 to 25, we expect his insurance cost to increase by $75. So, you know, there's that transformation had a huge impact on the way we are now interpreting these beta coefficients, or these estimates of the beta coefficients.